So we're going to look at more examples of graphing tangent and cotangent functions. So number 3, y equals tangent of 2 times the quantity x minus pi over 4. So let's write down what we know. First of all, the a value here is 1. So there's no vertical stretch or shrink. We can see that there is a b value here of 2. So just like before with the period, we want to take whatever the parent function period is and divide it by b. So in this case, we're going to take the parent function had a period of pi, and we're going to divide that by 2. So pi over 2 is going to be the period. And then in this function, we have a phase shift right pi over 4. So I'm still going to start this off the same way. I'm going to put the y-axis in the middle, but because I am moving to the right, I'm going to give myself some extra space over here. So I start with my 2 tick marks to the left and 2 tick marks to the right. And I'm always going to label these furthest tick marks with half of the period. So half of pi over 2 makes this tick mark here pi over 4. So then this one is negative pi over 4. And half of that is pi over 8. So this one's negative pi over 8. These tick marks can be labeled 1 and negative 1 because there was no vertical stretch or shrink. But now I have to move right pi over 4. So if I consider what my graph would look like, I would have vertical asymptotes here and here. I need to move right pi over 4. So that's 2 more tick marks. So I'm just going to add those in as well. So if each tick mark is pi over 8, here's 1 pi over 8, 2 pi over 8. So this is 3 pi over 8. And then 4 pi over 8 or pi over 2. So keep in mind, this was where your vertical asymptote was, here and here. So if we're moving right pi over 2, which is right pi over 4, which is 2 tick marks, then instead of the vertical asymptote being here at negative pi over 4, it's actually going to be here on our y-axis. And then instead of this one being at pi over 4, it's going to be over here at pi over 2. And then again, we would typically have started with our graph. We would have had a point here at negative pi over 8, negative 1, and then 0, 0, and pi over 8, 1. So we want to shift each of those points over 2 spots. So that means 1 tick mark away from where our vertical asymptote was, that's where this point's going to be, and it goes up from left to right, being tangent. That doesn't have a reflection. So then I could connect my points using that curve. And then again, I would always check a point. So 3 pi over 8, 1. If we wanted to check that, then we would be doing tangent of 2 times 3 pi over 8 minus pi over 4, which I'm just going to go ahead and write really quickly as 2 pi over 8, just so that these had a common denominator. So 3 pi over 8 minus 2 pi over 8 is 1 pi over 8, but then we're multiplying that times this 2. So this is really 2 pi over 8, which is really pi over 4. So we're looking for the tangent of pi over 4, which we know is 1, so it does check out. Let's look at another one. So this function here, we're looking at a cotangent function. So the negative 3 tells me that there's going to be a vertical stretch by a factor of 3. And it's going to be a reflection over the x-axis because of it being negative. There is no b value, which tells me that the period is still going to be pi units long. There's no vertical shift, and there's no horizontal shift or phase shift. So remember, with cotangent, we started the same way that we would have started our sine or cosine functions. So I put all of my tick marks over here to the right. I label that last tick mark with the period, which in this case is pi. So this is pi over 2 and pi over 4. So that makes this 3 pi over 4. This is the midline at 0 because there wasn't a vertical shift, but it was a vertical stretch. So I'm going to label this 3 and negative 3. And then remember, it's a reflection. So when I come back in to label these or put the points in, I need to keep that in mind. So for cotangent, I start and end with my vertical asymptotes. So I have a vertical asymptote on the y-axis and also on pi because we can't take the cotangent of pi. or the negative 3 times the cotangent of phi isn't going to work for us either. And then here, the period is taken care of. The vertical stretch just means that we're going to start with our negative 3 and 3s for our y coordinates. Typically, the cotangent graph starts up and goes down from left to right. So this reflection over the x-axis means this point reflects down here, and this point reflects up here, and the point that was on the x-axis stays put. So this graph, anytime it's a reflection of a cotangent graph, it's actually going to look a lot like a tangent function. And again, you want to get in the habit of checking points, but I'm going to let you guys do that on your own so that I can keep going through the video. So y equals the cotangent of x plus pi over 2. That means there was no vertical stretch or shrink. Because our a value is 1. The b value is still 1 here, so that means the period is still pi. So the only thing that happens here is that we're going left pi over 2. So if I want to go left pi over 2, I'm just going to leave some space to the left. But typically, remember, I would start with my 4 tick marks still over here on the right side. I'm just going to leave enough space to shift these to the left as well. So no vertical stretch or shrink, and it didn't move up or down, so the midline is still on 0. The period was pi, so pi over 2, pi over 4, 1 pi over 4, 2 pi over 4, so this is 3 pi over 4. If I'm going to move left pi over 2, again, that is 2 tick marks to the left. So I'm going to, in addition, add in these 2 tick marks, and each one is worth pi over 4. So here's negative 1 pi over 4 and negative 2 pi over 4, which is pi over 2. So cotangent typically starts here with the vertical asymptote on the on the y-axis, but shifting it left 2 means it's going to start here. And typically it would be here. Left 2 means our vertical asymptote would be here. And the graph goes down from left to right. So negative pi 1, 0, 0, pi over 4, negative 1. And then you just want to connect those. And again, check your points, check your coordinates to make sure that those actually work. Last one, number 6, cotangent function. In this case, I see we have a b value, so that means that this is going to impact the period. So the period is you take the parent function period of pi and divide it by b, so pi over 2. And then here I can see that we're going to be moving right pi over 8. There is no vertical shift. There's no vertical stretch or shrink. So when I start this off, I'm going to leave some space to travel to the right. So we have our period is pi over 2, so that's here, pi over 2. So half of that would be pi over 4, and half of that then would be pi over 8. So 1 pi over 8, 2 pi over 8, so this is 3 pi over 8. And we could label these 1 and negative 1 since our midline is at 0. But we're going to move right pi over 8. That's going to be 1 more tick mark. So if I add that in, remember this was 4 pi over 8, so this would be 5 pi over 8. So for cotangent, we typically start on the y-axis with our vertical asymptote, so that means it shifts to the right. So it's going to start here and end here. And cotangent typically goes down from left to right. So we would have a point at pi over 4, 1, 3 pi over 8, 0, and pi over 2, negative 1. So we connect these to look like kind of half of those parabolas opening up and opening down, and then you can pick a point and check it.